Good afternoon. Welcome. Glad to see you here. I'm Steve Bartos. I manage the predictive analytics team, the small but awesome predictive analytics team at Worthington Industries. Here with my colleague Will Davis, a member of said team. And we're going to talk about two things. First, make a couple promises. One, we're going to absolutely help you come down off the high of last night. Now, I know it was a pretty sick party, but we made a guarantee to you. I just talked to my Tableau rep. If we can't recreate the excitement and entertainment value that you had last night, your conference is on us. And actually on us, I mean on Ron. So Ron couldn't be here. I figured he'd help me keep that promise. So we'll make that promise to you. The second thing we're going to talk about is how we, and really by we, I mean Will, have supercharged Tableau with R to help our quoting group get much better at how we price in the steel processing division. And here's what we're going to talk about. First, I'll lead you on a whirlwind tour, brief history of analytics at Worthington, keeping in mind, just to help you get an idea of how we got to where we are with this specific project. And then I'll pass the mic over to Will, and he'll talk about some of the early modeling attempts. He calls them misfires, but some of the learnings around how we were going to model against this problem, how he built an interactive user interface, which you're saying, well, of course, isn't that what Tableau provides? But it allows the user to select parameters of interest while they're quoting, and then generates the model based on those parameters, and also gives the user a view of the health of the model, the robustness of the model. Maybe you don't have enough data in the model, so you're going to see that red light that says, hey, you might want to just go to something more descriptive. But some really cool stuff, and then at the end, we'll just geek out. This will be like the trombone shorty part of the show. Just talking about the stack and some of the IT work that Will has done with our team to put together the technology to make this happen. All right, the brief history of analytics. So Will and I and another woman, we formed the predictive analytics team in the steel processing division. A month ago, we were elevated. I guess it's elevated to a corporate function. But for the sake of this discussion, we're talking about the steel processing division at Worthington Industries. I see some of your faces, you're thinking steel processing sounds fascinating. It absolutely is. What we do is we buy steel. We're the fourth largest purchaser of steel outside the Detroit 3, the automakers. We buy steel and then we do stuff to steel. We process it, right? We heat it up to make it more formable. We clean it, we cut it, we coat it, do all sorts of cool stuff. And then that goes on to a variety of end uses. There's uses in construction, heavy machinery, grain bin, culvert, but for the birth of analytics at Worthington, what's important to focus on is the 50 to 60% of our business that ends up in an automobile. Something as utilitarian as your seatbelt buckle, something more engineered like the rail that your seat rides on, or then like the super engineered products that end up in your transmission, for example. You go back 10 years ago, this is an actual picture. I know Tableau doesn't like it when we use clip art. This is an actual picture of the first predictive analyst at Worthington Industries. His name was Sunpreet. So about 10 years ago, we hired Sunpreet, and you can see he saw tremendous opportunity for changing how we do what we do in steel processing by better using data and analytics. But back to the automotive finished goods that we produce, there was strategically that part of the business we were struggling in. 50 to 60% of our business, we do a very poor, inconsistent job forecasting. And so there was strategic alignment on how do we better improve our forecasting for our automotive finished goods, right? And there's plenty of ways. If you're in here at an R discussion, you understand there's a package for it, right? If you want to improve, you want to do statistical forecasting, you can find a package, right? And that'll get you a little lift, but that's not really the power that you're going to unlock, that next S-curve, how you impact the business with analytics. It really comes in with the data, right? So we went out, there's plenty of external data sources around automotive. You take a Ford Focus, we can figure out how many Ford foci they're going to build. But we did some additional work, legwork, and working with our end customers to collect data with them about where our finished goods go, right? And then you sprinkle in some secret sauce, and what we ended up with is what we affectionately call the crown jewel of analytics at Worthington Industries. And when I say that at Worthington Industries, there's always like a fanfare of trumpets and confetti cannons go off. That's the crown jewel of analytics at Worthington. And so then the question was, well, what do we do now? So 4 years ago, our then president of steel processing processing, who's now our COO, said, we got to figure this out, right? That's great. We had a big win. We improved forecasts. We carry less inventory. We carry the right inventory. Flow through our factories are better, and we're meeting customer service expectations. Okay, what do we do now? There has to be more opportunity. Go back to those sticky notes. There's 10,000 sticky notes. There has to be some strategically aligned opportunities for analytics. I come on about 4 years ago, and that was the task, right? This framework, I'm not sure if you're familiar with Tom Davenport's work or the IIA group. A couple frameworks were in place. There was a team that had been meeting, a cross-functional team, to talk about this. And one of these frameworks that we started to use when we talked to the business, when we talked to leadership, was about considering the questions we're asking of our data, right? First would be, do you have the data to answer your biggest business challenges, right? If you don't have it, we better figure out a way to collect it, because without it, you're not going to ask any questions of it because you don't have it. But secondly, we talk about, let's think about the questions we're asking of our data. And you can see across the columns, there's the rear view mirror facing data. Hey, every quarter we look at our sales and we see where there's some delta against our goal, we take action, right? But as you move out, as you move down and to the right, we understand that similar to that automotive predictive forecasting model, that's where the value is, right? That's the point of competitive differentiation for us. So we put that in front of the leadership team and various levels of the organization, but it was how do we start asking better questions, more value-added questions. So we partnered with a consulting group that helped us on an extremely successful, extremely expensive, but extremely successful transformation of our business. They came in and gave senior leadership a quick overview of analytics, and like any good consulting firm, just scared the crap out of them. We were so far behind, everyone's doing it, everyone's doing whatever. Maybe it wasn't digital then, but it was. And it was successful because the ideas were flowing, a lot of top secret ideas, we had to blur this out, but there were ideas in supply chain, commercial, and operations of how we can move the needle with analytics. And so we did what any predictive analytics team of 2 people would do. We had leadership sign us up for 9 projects running concurrently. Bad thing was, Steve develops a bleeding ulcer, loses like 15 years off his life. Positive part, we drafted Will Davis on the team, or Will was voluntold that he would now be a member of the esteemed predictive analytics team at Worthington Industries. So one of those projects was this price elasticity project. And you can read there the business problem. So this was about 2.5 years ago. You can read the business problem, but in a nutshell, it's we quote business for our customers. And what we had was, how many quotes did we win? How many quotes did we lose? How many quotes did we have in process? At the end of the quarter, at the end of a bidding season, we could talk about how many quotes we won, how many quotes we lost, and how long it took us to get those quotes out. What we didn't know is, hey, for a specific region, for a specific product, are we getting what we should be getting, right? Are we getting a premium for the product that we're processing? No idea, right? What about our loss data? Oh, wait, that's on like 42 different hard drives throughout the company. When we lose, we just sort of put it aside. When we win, there's a whole process that comes into place, but we didn't have the loss data to even get to something as aspirational as a price elasticity model. Something else we throw out there, and this is a testament to the champion of this project, and it was, hey, we could take all our financial data, right? When we win a quote and we process material and we send it to our customer, there's all sorts of financial data. So for everything that we've won, we can go through and look at, hey, we bought it for this, we told the customer this, here's how much money we made. But that's not, you're not going to build a price elasticity model like that, right? If you go back to that 6 box, we're still maybe on the top and over in the rear view mirror looking as far as the questions we're asking of that data. And what he said was, no, we're going to change how we do this process, right? We're going to disrupt our quoting group, and we're going to find a way to collect this data. Very messy data. I don't know how long the tables are, 40, 50, 60, however many fields there are. We're going to put processes in place to collect the right data because the end goal is a differentiator for us. And that's what Will's going to talk about as some of the steps that we've gone to answering that question. And here are some the last thing I'll say about this before I turn it over to Will. We did use that data. We did use that financial data. In my hands, it was maybe a little bit better than worthless. So this is a couple years ago when I first learned Tableau. I was in charge of this project. Why? I don't know, because there was 3 of us. And hey, you get supply chain, you get commercial, you get operations. But what was fantastic, just a quick success story about Tableau, we put it in the hands of a subject matter expert, someone in that group who had never touched Tableau, and it really revolutionized his work life. He talks about how I would go to work, we'd run through quotes. I learned Tableau, and he's absolutely energized. He's a tremendous contributor to that group. And you can see he's branded some of these tools and productionalized them in the quote group, our scope group, we call them. But again, if you go back to that 6 box, we're not going to get predictive, prescriptive with Tableau without some of the supercharging that Will did, right? We're starting to cover that area. The question is, to really differentiate ourselves competitively with this data and these analyses, we need to obviously ask better questions of our data, and that's where I turn it over to my esteemed colleague, Mr. William Davis, with 1L. Sorry.
Thanks.
Yep.
Am I on? Can you guys hear me? Okay, thanks. So the reason Steve walked through that background is because how we got here, some of the decisions we made during the modeling process are a result of the backstory and the development of analytics at Worthington and sort of the culture that surrounds it and how we look at data. So when you think about price elasticity in a traditional sense, you expect that as your price goes up, your customers are going to buy less. They're going to have varying levels of sensitivity throughout that range of prices. We kind of knew that. We were hoping that our data would help us get a little bit more specific around quantitatively what does that mean and how can we start to use it on an individual quote-by-quote basis. Unfortunately, that's what our data looked like. And really no amount of transformations or fancy math is going to get the points on the right to resemble the curve on the left. So we had to ask ourselves, okay, how are we going to deal with data that's shaped like this? There's got to be other ways to cut it, because we know inherently in economics that as demand goes up, or as price goes up, we expect our demand to fall. So we know that our business has to follow that path. The way we have the data now doesn't look like that. So how do we peel it back? How do we start to transform it to get it in a way that's going to show us what we know is there? So to talk about that, we first have to understand a little bit about our steel. So for those of you that have never seen it, that's what a steel coil looks like before it ends up in your seat or in your clutch plate or in the side of a combine. It has a lot of attributes to it. So if you think about a market that you're going to do price elasticity on, you're going to have some geographic components, things that are specific to your customer, things that are specific to your product. And where we faced the challenge was in how diverse our products are. And then that's sort of, in the title of the session, we say high mix, low volume. It's because most of our coils of steel look very similar, but when you start to break it down, there's a lot of different components that are sort of below what the eye can see that changes their applications, changes the value and what we can sell them for. The first one is alloy, which is essentially just the carbon content of the steel in hundredths or even thousandths of a percent sometimes. And so whether there's a high amount of carbon or low amount of carbon can impact some of the different properties of it. It impacts who's going to buy it and what they're going to use it for, and therefore what price they're willing to pay. We've also got some geometric properties like the thickness and the width of the steel. So that not only impacts what people use it for, but it impacts the equipment that we can use to produce it. If they're specific enough, not as many competitors are going to have the equipment that can do that. That gives us a little bit of an advantage. And that too will change the shape of that curve. There's other chemical elements in the steel. Again, the ability to have those or not have those is sometimes customer specific. And then lastly, you've got the shape. So we can ship it to our customer in this big coil. Sometimes we ship it in blanks that are further processed into other things, into sheets that may go in a wall or something like that. So all of these properties just define the product. It's not 5 or 6 SKUs like it might be for a widget, a chair, a table, a product like that. It's very customized, for lack of a better word. And so the problem becomes, how do we define the market that we're going to be in to look at that elasticity? Where does one market stop and another market start? So the way that reflects in the model and in our data set, we only had about 8,000 quotes. And I say only because in the world of big data, 8,000 is, you wait a second, you've got 8,000 more data points in a lot of data streams. In our case, this was 2 or 3 years worth of our quoting history, because quoting's infrequent and we had just started collecting that data. So we faced a little bit of a challenge there. And the challenge is exacerbated by the fact that because of all those product attributes, in addition to different characteristics of the market and the customers, you've got a lot of variables and very few observations to spread those variables across. So we did what any new analytics team that wants to make an impression would do, is we built a big machine learning model. And when I say big, I mean small. But the result was, it was extremely overfit. We had the demand curve that looks like that, where a big U, you're not going to demand less as price goes up to a certain point, then you're going to turn around and start buying more once you cross a threshold. So we knew that we're running into a problem, but in order to figure out how to proceed, we had to peel that problem back a little bit. And so if we look at an example of one of the model's outputs, walking through a little bit of a decision tree, we'd ask, okay, is this a cold rolled product? Cold rolled steel is a little bit more specialized. It goes into some of the finer components of your car. Companies that can do well there tend to have a little bit of a competitive advantage, so we thought it would be a good place to start to look at some differentiation. So if it's cold rolled, if it's yes, okay, is it a strip product, which is just further refinement? If it is, okay, let's look at the price now. Well, if it's under $50, we tend to win. If it's over $50, okay, what do we do next? If it's under 60, we see that we lose. But if we look at over 60, we see that we win. And so now we found our problem. There's going to be confounding variables in there, which many people are going to understand that conceptually, that there's other variables in there that the model hasn't captured, or more likely in our case, we don't have enough observations of products or sales or quotes with those variables. So how are we going to account for this? How are we going to build a model to show us what we know is there? We know that our customers have pricing and buying patterns and behaviors, but right off the bat, we don't have enough data to just throw it into a big model and get an answer back. So our process forward was to say, well, we know that there are people in the business that do this every single day. That's a little bit what Steve was talking about earlier. We had this quoting process. We were just starting to collect the data. We were getting users in the business who were doing pricing every day, engaged with Tableau, learning about analytics. The company, the business users saw the value in it. So then let's leverage them. Let's leverage their engagement, and more importantly, their business knowledge. And so the way we're going to do this is we're going to let them use Tableau. They can choose how the model is built, and then we'll build the model for them behind the scenes using R. So this right here is the dashboard that sat in front of them during one of the early iterations, and it's not going to be the prettiest one you see this week by any imagination, though there's 1 or 2 sessions left today, so maybe it'll be the prettiest one you see the rest of the day. But the important thing is that the feedback we got is it was functional, and as I walk through the different components, it really helps the user understand the context of the model, what the model is telling them, why it's telling them that, and how it fits into what they understand about their business. So the first component of the model is the set of parameters that we have on the left side. These are Tableau parameters. So they're things that we've given them the ability to choose or enter very specific values. The first one is related to variance. When we're looking at price elasticity, we're fortunate. We're in a market where there's a liquid financial market for our raw material. You can go out into an exchange. You can buy steel, hot roll coils futures. It's not as cool as Bitcoin, but you can do it, and there's a price for it. And so when we're looking at what we're selling to our customers aren't just interested in the sticker price that they see, but how much are we varying from this underlying index? Because that underlying index is what drives a lot of contractual pricing across the industry. And so with that, we give the user the ability to say, okay, we're not going to model a price directly, but we're going to model a variance from this underlying prevailing market price. But do we want to use a variance that's a percentage or a dollar amount? Because in times of high volatility, that percentage can get pretty high. In times of low volatility, you may want to use a percentage rather than a dollar amount. It just depends on the situation. And again, without enough examples, it's tough for a model to pick up on that signal and that noise. But a user who's quoting the business every day will have that knowledge to know when is it right to use a percentage versus an absolute value. We then ask them to enter the current or the prevailing market price so that the model can take the historical data and normalize it. Because if that underlying index, if it was at $400 last year and it's at $800 now, we need to know that so that the quotes that were quoted at 400 can be sort of repriced into today's dollars before they're used to train the model. And then lastly, we give them the ability to enter in a price of their own that they think, hey, this is the price that we think we should be charging the customer. It may come from some market intelligence, maybe from an outside salesperson, or just their knowledge of the business, but it puts what they think maybe heuristically into the context of what the model is telling them the price should be. And we'll see a little bit later on how that is incorporated into the output. So the things I walk through, choosing the variance type that they want to use, entering the market price, and then giving them the ability to do a little bit of sensitivity analysis. The second set of options we ask them to choose are that filters, and this goes back to what I was talking about before. When you're trying to do the elasticity calculation, say, okay, we're going to do the elasticity for this particular market. How do I define what this market is? And as I was talking about the features of steel, they're choosing, hey, it's this product type, this deeper level product type. Maybe the contract type has an influence. If we've got enough data, let's do this analysis for a specific customer. Our plants are geographically a little bit dispersed, so by choosing the manufacturing location, if it's a competitive product in that particular region, then they may want to just look at historical data that comes out of that particular region, and then the date. So if we're in a period of fluctuating prices, and they may want to narrow the amount of training data that they use, so that we don't get noise from periods that don't represent climate that's similar to today. But if things have been stable and they want the ability to include more data, then they can open that price range back up. And so all of these filters are what has taken our historical set of data, of quotes, and narrowing that down to only the quotes that they want to be training the model to help them make the decision for this new piece of business that they're quoting now. What they see at the top is the historical data. It shows the wins and losses based on all the parameters they've set, all the quotes that meet those criteria. These are all the quotes in the past that fall into that particular category, that particular market. The wins are at the top, the losses are at the bottom, and you've got your price along the horizontal axis there. There's a tooltip that gives them a little bit of information about each of those quotes. If they see an outlier and they want to investigate it further, they can take each quote has an identifier. They can go look it up in our quoting system if they want to know a little bit more about it. But the key component here is why that chart or that plot is in the format that it's in. Because we really have a binary variable. Either you won the quote or you lost. So why are we showing it this way? And the answer is to start to give the user an idea of the model that's going to be built underneath. We're going to be using the logistic regression model because we're trying to predict wins and losses. And though we're not expecting the user to fully understand how a logistic regression model works, they probably understand how a linear regression model works from a middle school or high school class. And we can build on that a little bit and say, okay, similar to that, we're going to draw another line through your data here. This is probably what that line is going to look like. It's going to roughly curve from the top to the bottom. And as you see that, losses are 0%, wins are 100% when it comes to, okay, what's my probability of winning? And then this line shows you what price points result in what percentage between 0 and 100. And so we have our wins and losses, and we use then price. It's a univariate model, and we predict what's the probability that we're going to win a quote at each price point along this continuum. It looks similar to a demand curve, which is the goal. You typically see, quantity and price. We have percentage chance of winning versus price because we work in a quoting type of process, where instead of people coming in and buying something off the shelf in varying quantities based on the price, we go through an RFQ process, and generally it's all or nothing. You either win all the business or you lose all the business. And one of the advantages we have is we have a little bit better grasp of those losses. In a retail environment, you may not know how many people come into your store, look at something and say, I was going to buy that, but now I'm not. And they walk out. You don't have a good idea of that lost business. We're fortunate that we do. We don't have as much volume of data as people walking through stores and buying things, but we know the other half of the equation. And so that allows us or causes us to use a logistic regression model to predict that probability. And you can see a little bit of the code in the bottom left, and I'll get into the detail of that a little bit later on. But for the purposes of it now, it's just we're running a logistic regression model to get our win probability as a function of price. And we say, okay, that's great. But then the question becomes, well, we don't want to win 100% of our business because our price is probably too low, and we don't want to obviously lose 100% because it's likely our price is too high. But that's the Goldilocks question. Where is the right place along that continuum for us to price so that we're winning as much as we want, or we're maximizing some measure of value to our company? And so we introduced using the idea of expected value, where you take your sales price multiplied times your probability of winning, and that gives you your expected value. It's a little bit hypothetical. If I do this quote 1,000 times, I quote at $100, I've got a 75% chance of winning. On average, I'm going to end up with $75. And so that's how we've taken that percentage and say, okay, assuming a relatively simplistic world, where should we set the price? And that's what the graph on the top shows you, is how's that expected value change as your price changes. And then we talk to our pricing analysts and say, okay, the math says that we want to price as close to the top of that curve as we can. And with Tableau, we add in the reference line that shows where that maximum price is, and then they can follow it down on the curve to see what the probability is and things like that. Lastly, I talked about earlier, they have the ability to enter in their own price for sensitivity analysis. And what that does is it draws the vertical reference line on there so they can see sort of the distance between, hey, maybe my customer is telling me I need to be at a certain price, or my sales guy is. How does that compare to what the model says? And then ultimately, what's our leakage from whatever the theoretical economic maximum could be from that quote? How much are we leaking by pricing low? And maybe that's okay. Maybe we want to price low because we've never quoted this customer before, we're trying to get in the door for future business, or we know that our quality hasn't been great as of late and we need to make sure that we retain this business, and so we're willing to price a little bit lower. And those are the things that if you had an extremely large data set, you could pick up on those signals, but with a data set as small as ours, we don't have the data to do that, then we're going to rely on the user to understand that. But we're going to give them the best model that we can with the data that we do have. And then from there, they can deviate from it as they see fit. Now, obviously, one of the risks with giving our users that much power without anybody looking over as they're training the model, because this model gets retrained every time a user selects a different set of parameters, defines a different market. And they don't have somebody from the analytics team or a data scientist looking over their shoulder saying, that model's okay, that one's not okay. And so we had to put in a mechanism for doing that. And I don't know, there was a talk at the end of the day yesterday, and I forget the speakers from Tableau that talked on a similar topic. But they talked about, okay, if you're going to deliver this, how do you give the user feedback on what's happening underneath, and is it reliable? Because right now we're just pumping some colors and some lines out at them, and they may trust it, they may not. And if they get burned by it once, are they going to come back? So how do we build some of that trust in with our end users? And it's relatively simple, but we do it with this stoplight. At Worthington, we have a pretty strong culture of lean and continuous improvement. One of the things that they talk about lean is you want your signals to your employees to be binary, red or green, win or loss, easy to understand, easy to know what action to take. There's no ambiguity to it. And so we give them a stoplight. Stoplight's green if the model's good, it's red if the model's bad. Well, then the question becomes what's good and what's bad. And when they hover over it, they get a little tooltip that gives them a little bit more information. So if it's good, we'll tell them the model's good. Or if it's bad, we'll tell them it's bad. We may explain why. And then at the bottom, we've included some of the parameters from the model. That way, if we need to dig deeper, if they need some help, somebody from the analytics team can go over and support them. We can see, are there problems with some of the coefficients? Is the p-value not as strong as we need it to be? So is it struggling from a statistical perspective, or is it statistically valid but struggling from an economic perspective? And what I mean from an economic perspective is we all have a kind of intuitive understanding of what's valid and what's not when it comes to demand curves. And if we see a situation where the model is showing, hey, as price goes up, our probability of winning goes up, then alarm bells start to ring in our head. Now, again, because of our smaller data set, that was a risk that we would run. and with giving the user so much control, they may find a pocket of the market where we've raised prices on our customers, and because we control that market, we do pretty well. But now that data is going to show that, hey, you can just keep raising prices as much as you want, and your demand is going to keep going up. So how do we look out for that? And that's where we bring R in again. We do a little bit of calculus, and we can understand the shape of that curve under the hood, and look at, if you look at just the first derivative of that curve to make sure that it's always increasing or always decreasing, and if you see that it's increasing at any point throughout the curve, then you know, okay, it looks like something here is going wrong. Maybe, from a statistical perspective, the p-value is low, the accuracy was strong, the coefficients, the coefficients may have high p-values themselves, but they're indicating that the curve is increasing, and we know that just doesn't correlate to a functioning market, if you will. And so the model is going to say it's good mathematically, but we need to walk them back and say, hey, economically, we know this isn't valid. And in that case, the stoplight's going to turn red, and they know that, okay, they need to go back and take a different look at some of the filters and the parameters that they've chosen. So that's sort of the front end or the user interface side of the model. Then after this, we'll get into a little bit of what's going on under the hood and why we designed it that way. But what made the journey successful, and how did we take a viz that's not the prettiest viz, that's got a lot of math going on under the hood, and get people to buy in? And you have to make sure that you're solving a real problem that they have. They know that they're collecting this data. They know that there are times that we win when it doesn't make sense, and we lose and it doesn't make sense. Customers are always going to tell you it's because of price. Your sales guys especially are always going to tell you that it's because of price. But do you have the data to back that up? And do you have the data to say, you're telling me it's price, but if I look at what's happened in the past and what's happening now in similar markets, I can tell you that it's not price. And so making sure that you're solving a real problem so that the business is engaged, and it's a tool that if it breaks, are you going to get a call? Is somebody going to call you and say, I can't do my job because the tool that you built for me is broken? And if nobody makes that call when it breaks, then you have to take a step back and say, are you solving one of your biggest problems or not? You have to be aligned. So using R and standing up a Tableau server that connected to R, all that happened at the same time as we were trying to deploy this model. So we were getting folks on the IT side having to stand up hardware for us. On the analytics team, we were integrating the two at the same time. And then we're trying to get our salespeople, our pricing people trained up on Tableau, getting them access to Tableau Server, and making sure that they not only knew how to use Tableau, but how do they use the model that we've built for them. And so alignment across all three groups is important, because if you are solving one of your biggest challenges, then everybody's going to be on board working towards that same common goal. You want to introduce complexity in pieces. Steve showed you 2 or 3 iterations of what the tool looked like before this. This wasn't the first time these folks saw something related to their pricing process. It's just the latest in a continuum, and we've got further iterations than what you've seen up here. So if we try to throw it all on them at once, then they're going to have no context for why are we giving this to them, what do we expect them to do with it. And going along with that is allowing users to see their data. So in our case, they'd never seen that data before, that win and loss history, as Steve said. We just started collecting it. So we showed it to them in that top plot where they could see their wins and losses and how they won and lost across prices. But we showed it to them in a way that helped them understand how the model was functioning underneath. And so they can see, hey, this quote, I remember doing this quote. You can tie the pieces of data that they're seeing on the screen and in their models, tie it to something that they're experiencing and doing in their job every single day. And so I'm going to close with walking through a little bit more of the technology stack and how it's built and why we chose to build it that way. And part of it selfishly is because as we were going through building it, I didn't find a whole lot in the Tableau community, and I'd like to start talking about it, and I'd like to hear other people start talking about it so that we can build, understand, develop best practices for how this integration is going to work. Because like I said, from my experience, not as many people were using it as I had hoped, or at least from what I could find through the community forums. So this is what our whole stack looks like end to end. I'm just going to walk through the pieces individually. So me as a data scientist, I build the models in R, and I don't put them directly into Tableau. I push them into our version control system, and I'll talk a little bit about why that is in a second. But the version control system takes the models that I've built, and they're built inside of an R package. And the reason they're built inside of an R package is a couple things. First, there's automated testing built into those R packages. You can use packages like TestThat to make sure that everything's building and running correctly and as you expect, so that when it gets out there in front of your users, it's not going to break. And if you're putting the code directly into just your Tableau calculated field, you're not going to get that. It's going to break right in front of them. They're not going to know what to do, and you're going to lose that engagement. The whole package infrastructure also comes with some built-in documentation, which I think in what I've seen a lot of times gets neglected, both on the data science side as well as on the Tableau side, putting tools and visualizations out there that are meant to be used interactively, but not providing documentation on what do these fields mean, how am I supposed to use it, when am I supposed to click on it. So at least from a modeling perspective, using R in that package environment builds in some of that documentation. So once that package is built, it gets pushed. We have an internal CRAN mirror because of security reasons. Our IT group doesn't like us going out and getting packages. Open source is new to a lot of organizations, so they actually just mirror every single night CRAN inside of our firewall, and then we build our package to that mirror so that if somebody wants to develop off of our package inside the organization, or if another application needs to go and get it, like RServe, it's available where all the other packages are going to come from. So from there, every night we have scripts that run that from our RServe server that goes out and checks to see if that package has been updated. So when we push updates to it, they automatically flow through. We do it in the middle of the night so that we can restart that RServe process without interrupting any of the business users. And then from there, the package gets called from inside Tableau. And so here's what that looks like a little bit more deeply inside Tableau. The screenshot on the right is what you saw on the first slide, where all we're doing is we're calling the library and the custom function that we wrote, and then the screenshot on the left is what that function actually looks like under the hood. And I think the biggest convenience, at least from the data science development perspective of building it in this manner, is that when you want to make a change, if you want to introduce maybe you want to introduce some type of sampling methodology, if we lose 70% of our business or our quotes and win 30%, you're going to have a pretty imbalanced training data set there. So maybe you need to do some down sampling or some up sampling. That's something that, an enhancement that you want to release. You'd have to go out to Tableau Server. If you're using a data source that's on the server in an extract, you're going to have to download that workbook. You're going to have to download the data source. You're going to have to edit the calculation on your desktop. And if you're using that calculation in more than one place, so if I'm not only pulling the predictions out of the model, but I'm pulling maybe the p-value, I'm pulling one of the coefficients, so it's duplicated in 3 places, I'm going to have to go make that change 3 times. And then I'm going to save that workbook. I'm going to re-extract the data source. I'm going to push it all back up to my server. And in this case, you have one output object from the model. In our case, it's that win prob. But you could go further, and you could, what we've done is when we want to extract the p-value as well as the prediction, we actually concatenate them together into one vector from R and return that vector to Tableau, and then inside Tableau, we parse that vector. Because it allows you to leave that calculation the same in Tableau and make all the changes in R. You can flow through the entire version control, the entire testing process that goes behind the scenes with RServe without having to touch Tableau. You can change the model type. You can change any of the pre-processing that you do, and all of it's done in an environment that's a little bit more aligned with data science. And then Tableau doesn't know any different. It's just running the same calculation from the same package, but it's getting the updated results. And so why build this infrastructure? The efficiency of continuous integration and continuous deployment. We can push those updates without having to do any work on the Tableau side, which makes it a lot easier for our users. We're not having to take those workbooks down or anything. And sometimes it can be a lot faster than having to download the workbooks. Stability and reproducibility of version control, and I know that version control is just sort of starting to ramp up on the data science side in a lot of cases, but it's really helpful, especially on a small team like ours, where if I'm out on vacation, somebody needs to go in and make a change, it's easy enough for us to work across one another. Automated testing, I think this is really big. One of the easiest ways, and there's a session yesterday that someone alluded into it, one of the easiest ways to lose engagement, especially with a tool that is a little bit higher performing or with a little bit more of things and events going on to help it render, the easiest way to lose engagement is for one of those things to break. And so when you have that built-in testing, the likelihood of those things breaking obviously is a lot smaller, and that's a huge advantage to retaining your users. The performance gains, so by keeping the R server and the Tableau server separate, it gives you some performance gains. They're not competing for resources, and oftentimes it's easier to support concurrency if you have multiple users hitting that workbook at the same time. Keeping them separate generally seems to perform better, especially if you keep that RServe environment on a Linux box. Then spinning up new processes is a lot smoother without not only competing for resources, but sometimes memory and variables getting crossed as well if people are using it at the same time. And then lastly, the security. This was actually the first big hurdle, and this is what led to the thought process for developing that entire stack, is when our IT department said we need that CRAN mirror to be inside of our firewall, and we got to thinking, okay, if we're standing that up, then what does the entire process look like? You know, how do we build it out further? If we're going through all this work, what's really the best way that we can do this? But you get that security of making sure that, and it doesn't have to be the entire CRAN mirror. It could be just your package, if that's all that you need. It, you know, in the odd situation, doesn't have dependencies. It doesn't have to be a full mirror. There are plenty of R packages that let you stand up a mirror that's just what you put into it. But again, that provides a lot of infrastructure on testing, documentation, et cetera, that you don't get elsewhere. So that was all that we had. You know, if you guys could fill out the survey, that'd be great, and we'd be happy to stick around for any questions.